You know, we always think of the future as something that kind of trickles in day by day, but sometimes it hits you all at once. In just the last 7 days, a wave of breakthroughs has completely reset what we thought was possible in energy, computing, and even our place in the universe. We're going to dive into what this means for the next 20 years.
And I'm not talking about some far-off abstract theory here. This is about real, tangible progress, stuff that happened just last week, that is rewriting the rulebook for how our world works. This is literally the blueprint for the next 2 decades, and it is happening right now.
All right, so where do we even begin with all this? Let's start at the absolute foundation, the physics. This past week, we didn't just nudge forward. We took a colossal leap in how we understand and control the tiny, fundamental building blocks of our reality.
First up, the big one, the holy grail of material science, room temperature superconductivity. I mean, just imagine it, electricity flowing forever with zero, and I mean zero, energy loss. It would totally transform our power grids, medical tech, everything. It's the ultimate goal, and we just got a whole lot closer.
So this number you're seeing, 151 Kelvin, it might not look like much, but it is a huge deal. Researchers hit superconductivity at this record temperature, but that's not even the main story. For the first time, they did it without needing constant crushing pressure. They used this cool trick called pressure quenching. Basically, they squeezed the heck out of the material, chilled it, and then let go of the pressure, trapping it in that perfect superconducting state. This is a total game changer, because now we can actually study these things with normal lab equipment.
And get this, it's not just about making these materials anymore. We can finally see them in action. Using a brand new kind of microscope, scientists at MIT actually watched the frictionless flow of electrons, this so-called superconducting gel. Actually witnessing this quantum jiggling is an unbelievable step toward designing these materials from the ground up.
Now let's connect this to the computer you're probably watching this on right now. Today, all our chips use electrons to shuffle information around. It works, but it's slow and it generates a ton of heat and wasted energy. But what if? What if we use the light instead? Researchers just created a tiny nanolaser that could replace those electrical wires with photons. The result? Communication at the speed of light with way less energy. We're talking about potentially slashing a computer's total energy bill in half. Think about that.
All right, from the fundamental physics of computing, let's talk about something that impacts every single one of us: power. A massive breakthrough in battery tech just dropped, and it promises to solve 2 of the biggest problems we have.
The secret sauce here is something called the electrolyte. You can think of it as a highway for all the energy moving around inside the battery. Now, conventional batteries, they have a pretty congested highway. It's got traffic jams. But researchers just cooked up a new kind of electrolyte that's like a wide-open 10-lane superhighway.
So what does that superhighway get you? How about this? Over 1,000 kilometers of range in an electric vehicle. That is more than double the energy density of the best lithium batteries we have today. That is a gigantic leap forward for EVs.
But it's not just about going further. It's about reliability. I mean, we've all heard the stories, right? How EV batteries just tank in the cold? Well, look at this. The old batteries fall off a cliff at -20 Celsius. This new battery, it's still crushing it at -50 and can even work down to -70. That's a huge problem, just solved.
Okay, we've got new physics, we've got new power. Now, what about the new intelligence? Because the biggest challenge with AI right now isn't just making it smarter, it's making it trustworthy. And that, surprisingly, all comes down to a math problem.
Let me ask you a question. Seems really simple. If you run the exact same AI with the exact same input on 2 different computers, shouldn't you get the exact same answer? You'd think so, right? Well, the crazy thing is, you don't. That's the reality today. And it's not a bug, it's baked into how our computers work. And this leads us to this really crucial concept, platform determinism. It's a fancy term, but all it means is a simple guarantee that an AI will give you the exact same bit-for-bit identical result every single time, no matter what kind of chip it's running on. Without that, how can you ever really truly trust it?
This is what researchers are calling the determinism thesis. And it basically says, look, if you can't guarantee the same result every time, you can't verify it, you can't audit it, you can't certify it for anything important, the entire foundation of trust just crumbles.
So what's the deal here? Why does this even happen? Well, it's all about how our computers handle decimal points. Different chips have tiny, slightly different ways of rounding, little math accents, if you will. And those tiny differences build up and cascade through an AI, leading to different answers. The solution that's been proposed is pretty radical. Ditch this unpredictable system and go back to pure integer math, which is perfectly consistent everywhere. It's a return to mathematical certainty.
Okay, so let's bring this all back from the math inside the machine to the most incredible interface of all, the human brain. Just this past week, a major milestone brought what was once science fiction one giant step closer to reality.
China has just approved the world's first commercial brain-computer interface of this kind. And here's the gist of how it works. First, a tiny implant in the brain detects not the movement itself, but the intention to move. Then, software translates those brain signals into digital commands. And finally, a device, like a robotic glove, gets those commands and carries out the action. It's a direct line from thought to action.
Now this is way bigger than just one cool gadget. This is a watershed moment. Over the next couple of decades, think about what this unlocks. We're talking about restoring movement to people with paralysis, controlling amazing new prosthetics just by thinking, and creating entirely new ways for all of us to interact with the world around us.
For our final story, we're going to zoom all the way out. I mean way out, to the cosmic scale. Because the James Webb Space Telescope just found something that, by all accounts, simply should not exist: an atmosphere on an impossible planet.
I want you to meet TOI 561b. This thing is a beast. It's a rocky lava world, twice as massive as Earth, orbiting so close to its star that an entire year, a whole year, lasts just 10.5 hours. It's an absolutely insane, scorched world where any atmosphere should have been blasted away ages ago.
But here's where it gets weird. The Webb telescope looked at it, and the numbers just didn't add up. If it were a bare rock, the surface should be almost 5,000 degrees Fahrenheit. But Webb measured it at a much cooler 3,200 degrees. That massive temperature gap, that is the smoking gun. Something has to be spreading all that heat from the day side to the night side, and that something has to be a thick atmosphere.
So how on earth is this possible? Well, scientists had this incredible new theory. They're calling it the wet lava ball theory. The idea is that the planet's molten magma ocean is constantly boiling off gases into the sky, and at the same time, the atmosphere's gases are being reabsorbed back into the magma. It's a crazy, self-sustaining system that's keeping this impossible atmosphere alive.
So think about it. In just 1 week, we've peered into the quantum world. We've redefined energy and computing. We've laid the groundwork for AI we can actually trust. We've merged mind and machine, and we found a world that basically defies science. We are actively rewriting the rules of reality. The only question left is, are we ready for what comes next?